Got the old ABB running the old time furnace with a 3-phase motor installed. So this was the original, and your old 48 frame here, as you can see. Now this guy here was drawing 4 amps of power. It was actually like 4.1. He says 4 right there. 4 amps was the current draw on this one. Replaced it with a Baldor 3-phase motor, and it's actually running right now, and it is drawing 0.8 of an amp. Instead of 4 amps, it's drawing 0.8 of an amp. Modern, old. Modern, old. So, if I could get it, come on. Okay, now I can't even get it open because it's sucking, because it's under vacuum. So we're running right there. There's absolutely no heat to this thing. It's been running for over an hour, and it's not even so much as warm. Can't feel anything. This was just temporary. This is not how it's gonna be. I was just rigging it up so I could get it running because I was doing the gas and everything. But got it running right now, and instead of drawing 4 amps, 0.8 of an amp. I'd say that's a little bit more energy efficient than old motor from the 50s and 60s to a nice new 3-phase Baldor running off the ABB. This is I think the 150 model. I forgot which one this was. I mean the 550. Yeah, so this is the 550 model. We got several years ago. This is what my son hooked up. Yeah, the AC S550. And that was my son's first job when he was learning about 3-phase motors, and I gave him the job before he ever went out and worked on any customers and started learning out in the field. Like my dad said, you don't learn out on the field, you don't mess up customers' equipment first. While you're learning, you learn on your own stuff. You don't learn by making mistakes. And so this was my son's very first electrical, and his first 3-phase motor, his first VFD, and so yep, just showing the difference in energy draw, power draw. Old one was drawing 4 amps of power. This draws 0.8 of a amp, and that's it. Do some catch up after I fix the electrical and get that back up. As you notice, when you're doing 3-phase power through an inverter, you don't use normal wiring. This is not normal wiring. You see this shielding here? This cable shielding? This cable shielding is wrapped around all these wires. Then it has the foil shield. Then it has a draw wire. And all these get wrapped around and grounded to the case of the motor. And they're all here, and you can see the foil right here and the draw wires right here. From coming out of here to here, you best have wiring that protects the whole system, including the whole building, because this will give off radio interference, because you have a pulsating DC signal that can have some very high voltage swings, and this thing will literally radiate like an antenna and mess with your TV or computers or other things inside your house. So from the motor, and this stuff is like, what was it, $6 or $8 a foot, and this was left over from a job, so I didn't have to pay for it. It was just leftovers. So you don't use regular wire. I had an electrician do a job for me, and he used regular wires, and it was causing ground, and it was actually developing 90 volts of current on the ground just because the wires were ran. Normal house wiring was ran in a conduit, and it was literally developing 90 volts through the magnetic interference or radio, god dang, can't think of the word now, but like the RFI that was given off by the normal wires were developing 90 volts on the conduit. And he was wondering why he got shocked, because he didn't use the white wiring. After I took out all his wiring and I put back the correct wiring and grounding, that got rid of the issue. So anytime you play with a VFD, read the instructions, and grounding is extremely important to you. All right, see you guys later. Like that, 8 amps, or no, 8/10 of an amp instead of 4 amps. A lot more energy efficient. And this is going to be put on a fan only mode, where it cuts the RPMs all the way down, not the RPMs, but the CFM all the way down. I'll run the motor at roughly 50% or less, and putting a near HEPA MERV 16 filter inside the system, 2 of them, 5-inch deep, 20-inch by 30-inch, so there's no airflow restriction, so the static stays low, and that's the whole idea of it. So we can have a variable speed motor on here while it's heating. It could go on high, and when he has it on fan only, just for cleaning the air, for keeping the whole house circulated, it'll go down to a low speed. Something that was not available at the time when these furnaces were produced. See you guys.